So we're doing 6.6b, and we're just going to do some vocabulary first. So when we have points that are all in a line, and we can draw a line through it, we call it collinear points. So here we have the word line. So whenever the points are in a line, we call them collinear. And it could be 4 points, 5 points, doesn't matter. It doesn't have to be 3 points. Okay? Here we have some points, but they're not collinear. They're not all collinear because I can't draw one straight line through them all. So we'll use the word collinear in the class. And you have to know the difference between lines and line segments. Lines go on forever and ever and ever, and that's why we put these arrows on the end to say, well, I'm kind of lazy, I don't want to draw it anymore. It keeps going in that direction. But a line segment starts and stops. So you can have a line segment that looks like this, or it can have endpoints like that. We're not using line segments in the class, and we're not using non-collinear points. We're using collinear points, and we're using lines in the class. Also, what is a linear equation? So if you look, you see the word line. So linear equations are just equations that represent a straight line. And this is what we're doing in the class. Here's some non-linear equations. They're not straight lines. Okay, so these we're not doing in the class. We're only doing linear equations, so straight lines. So if we look at the title, it says graphing linear equations. So what we're going to do is we're going to graph straight lines. And I'm going to show you how to do that. Okay. It says draw 3 lines. What do you need at the end of both sides of the line? Okay, so normally that would be a line, but it's not in math class. You need to have these at the end. You need arrows. You need arrows at both sides of the line. So draw 3 lines. There's 3 lines. This is not a line, and this is not a line. They have to have arrows at the end for it to be a line. Are these 3 points collinear? No. Why? Because I can't draw a straight line through all of them. Because I can't draw a straight line through them all. Okay. Draw 3 points that are collinear. Okay, so I can draw 3 points. They're collinear because I can draw a straight line through them all. Let's do 4 points that are collinear. There's 4 points. They're collinear because I can draw a straight line through them. Circle the linear equations. Linear has the word line in it, so anything that's a straight line is a linear equation. That one, that one. These are not linear equations because they are not straight lines. So there's many different ways to graph linear equations, and I'm going to go through different ways to do it. So we can plot points. Plot points just means by putting points on the graph. I put the points on, and then I join it up, and it's a line. Okay? So the first thing that we do is we solve for y. That means to get y alone on one side. So see here, y is alone on this side. So it's already, step 1 is done. Then we have to make a table of values. So here's a table of values. And then we choose some numbers, some values for x. We choose small numbers, so numbers that are easy. We substitute those into the equation and find out what y is. And then these become our points. So here's the first point, here's the second point, here's the third point. And then we plot the points, and then we join them up. And then we have graphed a linear equation. So let's go through and do that. So let's look at the first one. We're on page 3. Okay. It says graph the lines by plotting points. So we're going to plot the points and connect them with a line. So the first thing we have to do is have it y equals. It's already y equals, so that's done. Then we make a table of values, okay, and then we pick small numbers for x. So let's pick -1, 0, 1. Those are small numbers, and those are easy numbers. And if we keep them small, then they'll fit on the graph. So then I go, if x equals -1. So first we're having x equals -1, and we're going to find out what y is. So we copy this equation down, and wherever the x is, we're going to put brackets, and we're going to put whatever x is in the brackets. So here I have 2, and I lose 1, so then I only have 1. So that means if x is -1, then y is 1. And so my first point is this, -1, 1. That's my first point. If x is -1, then y is 1. So now let's do the next one, if x is 0. So if x is 0, let's copy down the equation, put brackets where the x is. Why do we put brackets where the x is? Because we're saying x is 0, so we have to change the x value. Wherever the x is, we're going to put 0. So now 0 plus 2 is 2. So if x is 0, then y is 2. So our next point is 0, 2. Okay, that's our next point. Now we're going to do it again, but we're going to say if x is 1. And we write out the equation. Wherever the x is, we're going to put brackets and substitute this 1 in. So if x is 1, we replace the x with 1, and we say y equals 1 plus 2 is 3. So now, if x is 1, y is 3. So that's my last point, 1, 3. Okay? So, when x is 1, y is 3. So x, this is the x-axis, this is the y-axis. So x is left and right. Oops, you can't see. So x is left and right, so it goes right 1 and up 3. So there's that point. Then we'll do this point. This is x, which is left and right, and this is y, which is up and down. So it says, don't go left and right, just go up 2. Now x is about left and right, y is up and down. This is negative, so it's going to go left. This is positive, so it's going to go up. So left 1, up 1. Left 1, this is left, this is right. So left 1, up 1. So you can see the points are in a line, they're collinear. Then I just put a line through everything. So I have graphed a linear equation. So this equation, when I graph it, looks like this. Let's do the next one. So it says by plotting points. We have to graph it by plotting points. So it's already y equals. So then I make a table of values. I'm going to pick some easy points. I'll just pick the same ones because they're nice and easy. So if x is -1, if x is -1, I copy this out. Wherever the x is, I'm going to put brackets because it says change the x value. So here, x is -1. Ooh, be careful. See how this negative goes in front, and then I put the brackets for x, and then x is -1, so there's lots of negatives there. So we can use our calculator for this. -1 plus 2, 3. So if x is -1, y is 3. So there's my first point. Let's do our next point. If x equals 0, now we write this equation out. Wherever the x is, I'm going to put a bracket. see how this negative stays in front, and I put the brackets just where the x is. Now x is 0, so then I have y equals, what's negative 0? It's still 0. So this is 0 plus 2, which is just 2. So if x is 0, y is 2. Now, if x is 1, what's y? So write out the equation. Wherever the x is, I'm going to put brackets. And x is supposed to be 1, so I can replace the x with a 1. So that means I have 2 and I lose 1. If you don't know, we can just do exactly that in the calculator. So I have 2, but I lose 1, so I only have 1. So if x is 1, then y is 1. So my last point is this. Oh, this was my second point. And this is my last point. Okay, so this is right, left, up, down. So the first one is x, and this is y. And x is always left and right, and y is up and down. So here's x and here's y. So because this is negative, it goes left, and because this is positive, it goes up. So it goes left 1, up 3. Left 1, up 3. There's my first point. So that's x, y, left and right, up and down. 0 means don't go left or right, just stay. This is positive 2, so let's go up. So stay, don't go left and right, and go up 2. Now this one is 1, 1. So this is go right 1, go up 1. Go right 1 and up 1. And you can see with your eyes that these points are all in a line. They're collinear. And I'm going to do something wrong. There, I joined it up. That's wrong, because that's a line segment. That's a piece of a line. We want to draw a line, so we have to extend the line past the points and put arrows on the end. Okay. So now let's go, you finish the page by yourself. Okay. And now I'm going to go to the next page. Now it says, graph the linear equations, that means like straight lines, equations that represent straight lines, by using intercepts. So what is an intercept? So if I have my graph and I have a line, the place where the line touches these axes are called the intercepts. So here, the line touches the y-axis here, so we call it the y-intercept. And here's my x-axis. The line touches the x-intercept here, or touches the x-axis here, so it's called the x-intercept. Okay? How many intercepts do we have? 2. So how many points do we have to find? 2. Okay? And it's exactly the same as before, but you don't have to have it y equals something. You can just have it looking any way you want. You make a table of values before, but now you let x equal 0 and y equal 0. Okay? So let's do that. So the first thing we do is make a table of values. Well, let's read it first. Graph the lines by using the x and y intercept. How? You can't see. Graph the lines by using the x and y intercept. How many are there? 1, 2. So that's where we make a table of values, and we only do 2 points. We say if x is 0, what's y? If y is 0, what's x? So let's do x first. If x equals 0, now we copy out the equation. Now where do we put our brackets? Under the x or the y? Under the x, because here we're saying if x is 0, so we're going to replace the x with a 0. So 4 bracket bracket. So instead of x, we're going to substitute a 0 in. What's 4 times 0? 0, so it's gone. So I just have 3y equals negative 12. Now y needs to be alone, so I have to get rid of the 3. To get rid of the 3, I have to go same over same. What's 3 divided by 3? 1. So there, that's really 1y equals, I'm going to use this button, negative 12 over 3, negative 4. And that's the same thing as y equals negative 4 because the 1 can hide. So we're saying if x equals 0, then y equals negative 4. So if x is 0, y is negative 4, and that's a point. Now we're going to do the other way. If y is 0, so if y equals 0, copy out the equation, and wherever the y is, we're going to put brackets. And we're going to replace the y with a 0. What's 3 times 0? 0. So really I have 4x equals negative 12. And I want to get x by itself, so how do I get rid of the 4? Yeah, I divide by 4. Same over same, because that's 1. So 4 over 4 is the same as 1, so I have 1x equals, and now I have negative 12 divided by 4, negative 3. That's the same as x equals negative 3. So if y is 0, x is going to be negative 3. So that's my second point, negative 3, 0. And then this one is 0, negative 4. So those are my 2 points. So let's do this one first. This is x, this is y. X is left and right, y is up and down. Because it's negative, it's going to go left. And oh, this says don't go anywhere. So it says just go left 3. 1, 2, 3. So you can see it's on the x-axis, so that's the x-intercept. Let's do this one. X, y. X is left and right, y is up and down. So it says don't go left and right, only go, because it's negative, it means down. Positive would mean up, so I have to go down 4. Don't go left and right, just go down 4. So there, this is my y-axis. How do I remember this one's y and this one's x? Y looks like this, so it's up and down, so that's my y-axis. So now I have 2 points, my x and y-intercept, and I just do like that. Connect them with a line. So I graph the lines using the x and y-intercept. There's my x and y-intercept. Let's do another one. Let's do this one. So I just go make a table of values if this is 0 and if this is 0. Let's do x first. If x equals 0, copy out the equation, and wherever x is, replace it with the 0. So I'm going to put brackets here. So instead of x, I'm going to put a 0. What's 2 times 0? 0. So I only have this left, negative 3y equals negative 12. Y needs to be alone. Do I have to get rid of the 3 or the 12? The 3. I'm going to do it wrong. Why is this wrong? Because it has to be same over same. This is negative 3, so you have to put negative. So negative 3 over negative 3, that's 1. So that's really 1y equals, and let's use our calculators, negative 12 over negative 3. Whenever it's the same, it's going to be a positive. And 12 divided by 3 is 4. So y equals 4. So now, if x is 0, y is 4. So there is my first point. 0, 4. Now let's do the second one. If y equals 0, what's x? So if y equals 0, copy out the equation. Okay. So now, where do I put my brackets and my 0? Y. Because I'm saying y is going to be 0, so I go 2x minus 3, put my brackets here. And instead of y, I'm going to replace it with the 0. 3 times 0? 0. So I really just have 2x equals minus 12. Now x needs to be alone, so do I get rid of the 2 or the 12? Yeah, the 2. because he wants to be alone. So divide by 2, divide by 2. 2 divided by 2 is 1, so that's really 1x equals, they're not the same. That's a negative, that's a positive, so it's going to be negative. 12 divided by 2 is 6. So x equals negative 6. So here, if y is 0, x is negative 6. So that's my last point. Negative 6, 0. There. So now let's graph the first one. That's x, that's y, left and right, up and down. So it says don't go left and right. This is positive, so it means go up. So don't go left and right, just go up 4. Is that my x or y intercept? Well, because this is y, that's going to be my y-intercept. This is my x-axis. So, x, y. So this says, because it's a 6, and because this is x, it goes left to right. Because it's negative, we're going to go left. If it was positive, we'd go right. So this says go left 6, and don't go up and down. 1, 2, 3, 4, 5. Oops. Let's just pretend it goes there. Let's pretend the graph is a little bit bigger. Now, okay, that's kind of messy, but you can see. So, because this is my x-axis, this is the x-intercept. Because this is the y-axis, the line touches the y-axis here, so this is the y-intercept. Okay? That's the y-intercept, that's the x-intercept.